already done vectors diagrams when there's just one dimension. For instance, the man running there, and then the man running back a little bit. Nope, that didn't work. Okay, I need to work out the resultant, and you all did that really well. And then in more advanced, slightly more advanced, is you had to work out the resultant if it was 300 metres that way, 800 metres that way, and you had to work out the resultant, and it was from start to finish, and you worked it out really well. The only mistake is some people forgot to realise that bearings are always from the north line round to the tail of the resultant. So you work at this angle and then subtract it from 90 to get this one here. Okay? But what we're going to look at now is a situation where you don't have the luxury or the ease of having angles that are just 90 degrees bearings, vectors that are 90 degrees to each other. You're going to have some where they are actually at angles between 0 and 90 or more than 90, and you have to be able to cope with that. Okay? So let's just take this one here, let's take this situation here. Actually, I'm going to make it so that it's not, I'm not going to work, just take it as a triangle just now. Okay, so let's call that A, B, C. I'm going to call this angle here big A, this is big B, this is large C. Alright, and you have to know the cosine rule, which is that A squared equals B squared plus C squared minus 2BC cos A. You also have to know the sine rule, which is that A over sine A equals B over sine B equals C over sine B. Now a wee glitch in the video, so it might jump about a little bit, but what we're going to look at is a problem where you've got a plane flying north at 100 metres per second, and there's a crosswind. It's very windy today, you can hear this window, doors banging in my house in the background, of 20 metres per second, and the bearing is 30 degrees. And what I'm going to do is go through that problem, and you'll see straight away that these two are connected. What's the resultant velocity of the plane? Okay, so the only thing that's wrong with this is straight away, as you see, these are connected tail to tail, and that won't work. So you've got to move that vector up. I can also move that vector down, doesn't matter, so that they connect. As long as the angle stays the same between the two vectors, stays at 30 degrees here, you can slide them across each other, so that there's the connected head to tail. So remember, vectors must be connected head to tail. Now that it doesn't include, except for the resultant. Okay, so I'm going to move on to going through that problem now. 100. So there's 100 metres per second, and here is my 20 metres per second. Now, I know that I'm not drawing this very well, okay, but it doesn't matter too much. I know that's 30 degrees, so that means obviously the whole angle here all the way around is 180, so I know that this must be 150 degrees. Okay, 150 degrees. That doesn't look anything like 30 degrees, I know that, but it doesn't matter too much, just do the best you can, it's a sketch. So the resultant, remember the resultant is always drawn from start to finish. So there's the start, perfect diagram, and the finish is up here. Now I've got to be careful, I don't want to get in the way here. So I'm just going to click, so what I'm going to do is I'm going to say, right, okay, that's my vector diagram, I need to have this drawn properly, so I'm going to draw it from there to there. Now the way I would normally show that that's a resultant vector, not one of my original vectors. I don't actually have the plane, I don't have, the speed is 100 metres north, and then a velocity of 100 metres north and velocity of 20 metres per second, a bearing of 030. So the red line there, this is my resultant vector. Okay, the question here is, how do you calculate the size of the direction of the resultant velocity? So what we do is we go, okay, let's try to calculate the size using the cosine rule. So use a squared equals b squared plus c squared minus 2bc cos a. So that equals 100 squared plus 20 squared minus 2 times 100 times 20 cos 150. You put that in your calculator, equals 13,864. Give you the square root of that answer, gives you 1,180. Now I'm just going to round up meters per second. But of course, as you know, that's not enough. That's just the direction. So you have to think, okay, how do I get the size of the angle? Now, you can see here the angle from the Taylor resultant round from the north line to the tail is there. I need this angle in here. Okay, so for this I use the cosine rule, sorry, the sine rule. So let's just say this A over sine A equals B over sine B. I don't have to use all three sides. So I know that the side that's opposite the angle I want is 20, so it's 20 over sine A, don't know what that is yet, equals, and I'm going to use 150, and the size of that is 118, so it's 118 over sine 150. So you get 20 over sine A equals 236. So sine A equals 20 over 236. So A equals 4.86 degrees. I'm going to make it 5 degrees. Okay, 5 degrees. So if that angle in there is 5 degrees, then we know that the bearing is at 005 is the resultant velocity of the plane. These are the kind of questions you're going to get, first of all. Now, you can see this one, and this one. This one's dead straightforward, okay? Angles nicely set up for you, vectors are nicely set up for you. Don't forget arrows and vectors. This one, notice that's connected. Notice how that's connected. This is trickier because it's not 90 degrees. This one's trickier, and this one looks hard, but actually, I would just give you a wee clue, which is, you can do that. Alright, and you should be able, from that, you should be able to work out, get a nice simple triangle. These ones, the same idea, watch there, watch there, watch there. This one is harder. Now this one here, I don't want you to do, because really that's to be done with you can have a go at it if you really, no, don't do that one, just do this one, okay, so do that one. So don't do this one, alright, we're not going to do that one just now. Go. This is fairly straightforward because this is a right angle. And that's okay. This is trickier because notice how they're connected, and you'll see you've got a headwind and it's slightly, you've got to connect these properly, and you'll have to use the cosine rule. Okay, so this one we need to use the cosine rule, this one here, cosine, and a couple of others over here. This one cosine, this one cosine. Okay, and this one cosine. Now this one's tricky. Okay, that's a hard one. It's harder. So do your best with that one. but don't do this one, okay? I don't want you to do that. Forget this one just now, alright? Don't do B part B. Alright, so remember, any questions, go into the chat in the team